Let us see one of the example here. I take that is a cycle of construction here in the down. Okay, in this what is the input is required here? So regular expression. So this is you have seen that is a abbreviated register specification. You might have seen this in the any electronic subject. Electronic subject from 0 to 7 the registers. How to recognize it is, you can say, one of the expressions. Either your NFA is accepting R0, R1, R2, R3, R4, any one of them it will accept it. That pipe operation is pipe symbol is indicating either accepting R0 or R1 and like that, right? So now, so these are the register names. So it will start from 0 to 9. Start with a regular expression. This is this you can call as a regular expression. Okay, this you call as a regular expression. Now how do you construct that is, this is a regular expression. So now how to construct the NFA by using this regular expression. So one of the procedure need to use, that is Thomson construction procedure, that it will be learn how to do that. There is a separate procedure is there. In this module we will going to discuss in the third or fourth lecture class. Right, look at this, one of the transition diagram I have taken directly for explanation purpose how this cycle is works. First I have taken the RE. So what is the common in that regular expression is R is the common, right? Now, so it is start with a S0. Suppose if I want to R0, so whether it is go to, it is accepting, then it will take this path. So you know already any epsilon it can be able from one state to other state while accepting a epsilon. So you can take this path and go. Suppose if I say R1 has come, he'll take this path and take this is he'll go this path and so on. Okay, so now to make it is very and I1. So this is, you can see this is so big huge diagram. So I need to reduce that. I need to reduce these diagrams. How do you reduce them? So this is very important. Look at this. This is, you can say, NFA, non-deterministic finite automata. So I want to reduce by eliminating a epsilon. So look at, you'll go to the second one, subset construction build, because once NFA is constructed, you can able to construct a DFA. That is second part of it. Look at that, which is I have seen in the previous slide. The R is common in common. So that is you have to start with R1. Then if that is a R0, so R is common for in all 9 registers. So R will go to R0. If it is R1, it will go to this path, or if it is 2 or so on like that. This is a DFA, right? So you've seen that in a previous slide there is a big huge diagram. So there is a number of states are more. As I converted into the DFA, the number of state has been reduced. Still you can make, because you have seen this when you see this diagram, there are multiple finite states. There are multiple finite states. So still it can be minimize it, because 9 final states are there. So all of them are reached to the one of the final state. How to minimize the minimal DFA? That is the last step of this cycle, right? So this is, now you can make one of all this 9 final state is merged to the single final state. So that is, so earlier you have seen in the previous few slides before that is a big diagram on NFA. There are multiple epsilon transitions are there. So then you are converted into DFA. Then DFA is still you can minimize it. So 9 state you can merge to the single state. So R is common for all the 9 registers. Suppose your R0 you want to check, that is R it is common. and 0 it will accept. But one thing you need to remember, all these 9 input will not accept in one stretch. So depending on the input, it will read the character by character. So it is easy for you to construct a DFA. So this is the minimal DFA. Okay. So once you understand this concept, totally it is depending on that. So you can elaborate it. So here onwards you'll see that what is RE. So regular